1.1 Modeling Equation Solving. Tracking minimum wage, example 1. The numbers in table 1 show the growth of minimum hourly wage from 1995 to 2005. The table also shows the minimum hourly wage adjusted to purchasing power of 1996. Let's see, answer the following questions. In what 5-year period did the actual minimum hourly wage increase the most? Minimum hourly wage, purchasing power. Okay, where do I see the biggest growth here? A quarter, going up a quarter. 210 to 310, there's $1. Is there anything that's more than $1? I would say from 1975 to 1980 is where it increased the most by $1. Um, so 1975 to 1980. In what year did a worker earn the minimum hourly wage, enjoy the greatest purchasing power? Purchasing power, 1970, yes, $6.47. So the purchasing power was going up and then it went down. So I would say 1970. Yep, I would say 1970 had the greatest purchasing power. A worker on minimum wage in 1980 was earning nearly twice as much as minimum wage in 1970, and yet there was a greater pressure to raise the minimum wage again. So minimum wage $1.60. I remember this minimum wage. Oh yeah, that's where I started right here. It was $3.25, I think. It's not very much. All right. It increased from $1.60 to 310, and the purchasing power 647 to 590. 10.57 actually dropped 57 cents. Well, wages are going up, purchasing power is going down. You can definitely see inflation in that. Inflation was definitely affecting what was going on in this period of time. Yet it was why, I would say, because of inflation. All right, let's see. Example 2, analyzing prison populations. 1.2 table shows the growth in the number of prisoners incarcerated in state and federal prisons at the year's end for selected years between 1980 and 2005. Is the proportion of female prisoners increasing over years? Proportion. So I'm looking for a part to a whole. What do we have here? 13 females. Male, we don't need to worry about. And do need that for the total. So I would say 13 to 329. Is it increasing? We've got prison totals increasing, females increasing, seems likely. Let's do a few. 23 over 502, 44 over 774, 13 divided by 329 is, so that would be 3.9%. 23 divided by 502 would be 4.6. 44 divided by 774 would be 5.7. It seems like it's definitely increasing. Is the thing over the years? Yes. And you can actually see right here 3.9, 4.6, 5.7 that it is increasing. Yes. Example 3. A pizzeria sells rectangular 18 by 24 pizza for the same price as its large round pizza with a diameter of 24 inches. If both pizzas are the same thickness, which option gives you the most pizza for the money? What do I want to know about these? I want to know about the area. So area would be 18 times 24. Area is pi r squared, so r would be, r equals 12. Area equals pi times 12 squared. That's which option the most pizza? I would say that one. The round pizza is giving you the most. Which option gives you the most pizza for your money? That would be the round pizza. Example 4, visualizing Galileo's gravity experiments. Galileo Galilei spent a good deal of his time rolling balls down inclined planes, carefully recording the distance they traveled as a function of elapsed time. His experiments are commonly repeated in physics classes today, so it is easy to reproduce a typical table of Galilean data. What graphical model fits the data? Can you find an algebraic model that fits? Well, I would say if I have a table of values, I am going to go and do a scatter plot, see what's going on. It's the easiest way. So check my scatter plot up here. It is off. I'm going to hit enter, and it's blinking on. It's off right now, so I'm going to hit enter so that it's on, and then I'm going to quit. Regression would go to stats. And we want to edit our list. Number 1, enter. All right, cleaned out my tables. Remember that you go up, hit clear, and come back down again. So the first list will be X. That will be 0, 1, 2, 3, 4, 5, 6, 7, and 8. List 2, 0, 0.75. All right, the first thing that I need to do is I need to hit zoom 9 for zoom stats. Zoom 9 is zooming in on your stats, number 9. And you can kind of see what the shape of this is. I could do a regression. Do I think it's a linear function? Does it look like it's just going up in a straight? Does that look like the best function? I would say that this is more tending towards looking like a parabola. So I'm going to do regression for a parabola. We go to stats. We want to calculate at the top. Calculate. We did linear regressions. We can do quadratic regressions, cubic. Number 5, a quadratic. I have list 1 and list 2, yes. And I would like to store this equation so I do not have to keep writing it in. You go to variable. I want to store this equation into y equals, so I don't have to manually punch it in myself. So you go to vars for variable. I'm looking for a variable. I'm looking for the y variable. Scroll over. and number 1 is a function, and I want it to go to y1. Enter, enter, enter again, and I'm going to write this data down. We have x squared, ax squared plus bx plus c. There's our quadratic. Here's our a, b, and c. We know that a equals 0.75, b equals 0, and c equals 0. So we have a quadratic, y equals ax squared plus bx plus c. Y equals 0.75x squared plus 0 plus 0. So if this graph fits the data, then this will be my equation for the algebraic model. Let's see. I'm going to push graph. And we can see that that data fits it very closely. So it's definitely a quadratic. There you have it. Let's answer the question. What graphical model fits the data? That would be a quadratic function fits the data. And here's my algebraic model there. We showed in example 2 that the percentage of females in the U.S. prison population had been steadily growing over the years. Model this growth graphically and use a graphing model to suggest an algebraic model. All right. I am going to go to stats. Before I go there, I'm going to go to y equals, clear out my data, go to stats. We're going to edit the list, clear my data by going up, clear, clear. What is the data that we are using? I would say that this would be the table that I'm using. And you always start at 0 and then 1. No, that's not true. 0, and then it's going by 5. So that would be 5, 10, 15, 20, and 25. It went by jumps of 5. And then I'll be using this for my y value. So this is my x, this is my y, and I'm going to enter that in. 0, 5, 10. Looks good. Go to zoom 9 for zooming in on my stats. Okay, this is looking a little more linear. Doesn't have that curve. Let's do a calculation stats. Calculate. I'm going to do a linear regression this time. Number 4. Enter, enter, enter. I would like the calculator to store this for me, so I'm going to go to vars, variable. Scroll over to the y variable. Yes, it's going to be a function. And number 1, y1. Enter, enter, and I'm going to write my data down. I have y equals ax plus b for a linear function. Y equals, my a is, I'm going to say 0.13, so 0.13x, and then 4.1 plus, it's a positive 4.1, and r is close to 1, so that's a strong positive correlation. All right, let's go to graph. Yep. That fits pretty good. Solving the equation algebraically, graphically. So we have, I need to have them all in the same size. It's a degree 2. So I'm going to shift these two terms to the left. We get x squared plus 4x minus 10 equals 0. 5 and 2 are never going to add to 4. 10 and 1 are not going to add to 4, so it's no factoring. Then we would use the quadratic formula. All right, with the quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. We have here 16 plus 40. When we put them in the calculator, negative 5 5.74. That's algebraically. All right, algebraically, after punching that in the calculator, that's what we get. How about graphically? I am going to go to stat plot and shut it off. Second, y equals, not doing a scatter plot, so enter, shut it off, enter. All right, y equals x squared plus 4x minus 10. Graph. I see my window is all messed up, so I'm going to go to zoom. Number 6 is a standard 10 by 10. Start there. I am looking to solve for x. I need to know where it's crossing the x-axis. I can see them fine, so I'm not going to worry about my window. I'm going to calculate those zeros twice. I have a 0 here and a 0 there. Calculate in blue. I want to calculate a 0, number 2. It's asking for left bound. Where am I on the left-hand side of this intercept? When I'm on top. I'm watching my numbers, -2. So I don't miss it. There it is. Hit enter, and now I need a right bound, so I get on the right side of it. Enter, enter again. -5.74. Same thing I just got. One more time. We're going to calculate a 0. And this time we're going to be over on the right-hand side. I see that. There we go. It's asking for a left bound. Here's where I'm on the left-hand side of that intercept, equals. Now the right side, enter, enter again, and I get 1.74. So algebraically, graphically, I've just seen the same answer. Right. Example 8. The engineers at an auto manufacturer pay students 8 cents per mile plus $25 per day to road test their new vehicles. How much did the auto manufacturer pay Sally to drive 440 miles in one day? All right, there's no equation. I'm going to have to come up with something myself. Well, let's see what we have here. They both earned $25 per day, and the 8 cents per mile represents the pay would be 8 cents per mile. So 8 cents per mile plus a flat fee of $25 a day. And she drove 440 miles. So part A would be 0.08 times the 440 miles plus the flat. We're looking at the pay would be $60.20. John earns $93, so we already know how much he earns. He earns his pay. So 93 equals 0.08 miles per mile plus the 25. I just need to solve for how far, how many miles. All right, 93 minus 25, 68 equals 0.08 miles. And we see that miles equal 850. For failure, look at the graph in Z decimal window on the graph and calculator. Are there any x-intercepts? Y equals, we have 3 minus, and all of this needs to stay grouped together, so I'd feel better about putting it in parentheses. 1 divided by the square root of x squared minus 1. I need to get out from underneath the square root and then close my parenthesis and graph. We need to look at this in Z decimal. We can see that the graph is coming in and it's going down, but then what's happening? And so zoom, Z decimal would be 4. Gives us a little bit better of a look at it. Are there any x-intercepts? It doesn't look like it's crossing the x-axis. It stops. What is going on here? Let's take a look at, let's look and see what the table of values is doing. And we're at 9. So we're closer to 1. Numbers are getting smaller, and then it's error, error, error. So there's an error between when x is 1 and x is -1. Between 1 and -1, there's an error. There's nothing there. And normally when you see something like this, then you're thinking about some undefined places like vertical asymptotes. I would say no.